Question number 5. Solve the equation of 5 modulus 2x minus 1 modulus plus 8 equal to 23. Okay, whenever you see these two straight lines, this is a symbol for modulus. Modulus means distance from 0. So before we talk about the equation, okay, imagine a number line. And this is the center of the number line, which is 0. If something is 3 units away from 0, it could be here. It also could be here. Same distance, different direction. That's why whenever we have modulus, it's going to give us two answers. Now, let's look at the equation. Our first job is to isolate modulus. Now, if you remember AddMath, right? Dealing with algebra, we need to go from right to left. So we have positive 8 over here and 5 times over here. The first thing that we need to move is additional or subtraction, which is number 8. The second thing that we need to move is multiplication or division. So this is number 2, based on the sequence of which one to move first. So let's move 8 to that side. Moving positive 8 to the right hand side will make it minus 8. Now, let's move 5 to the right hand side. 23 minus 8 is 15 divided by 5. That would be 3. Now, this is the step where we need to remove the modulus. Since we know removing modulus will give us two answers of positive and negative, hence we can rewrite it in this form. 2x minus 1 equal to positive 3 and 2x minus 1 equal to negative 3. 2x equal to 3 plus 1, that is 4x equal to 2. 2x equal to minus 3 plus 1 is minus 2 and x is equal to minus 1. Now, modulus means distance and distance can happen on both sides of 0. Okay, let's bring in the marking scheme. If we make this 2x minus 1 equal to negative 3 and positive 3, we will get method 1 mark. So that is over here, M1. And when we get to our final answer of x equal to 2 and negative 1, that is answer 2 marks. Total mark is 3 out of 3. Question 5b. On the axis, sketch graph of y 5 sine x minus 2 for x from 0 to 360. Now, for this question, you need to start with the basic sine graph. And then we will apply the changes that we have over here, which is negative 2 and 5. You can download these free notes in the description box below. Let's start with parent graph. Now for sine, the key pattern is the midline, the maximum, the midline, the minimum, and the midline. So these 5 points are enough for an exam sketch. Let's focus on this 5 points. This is the idea from the transformation section. First, you need to know the general form, then only you can transform it. The number in front changes the height, how tall or how short it will be. The number outside move the graph up or down. So based from our question, this one will be the height. Let's try to visualize this graphically. Okay, this is a normal sine graph. If I put 5, you can see how high the graph will go. So A, negative 2 means the graph no longer start at 0, it will start at negative 2. Now let's sketch this. We know sine graph will start at 0 and its highest point is 90 degree. Going down and its lowest point would be 270. Okay, and negative 2 means our 0 will start from negative 2. So negative 2 is over here. It's going to start from there. And 5 over here means how high it will go up. So from the 0, it will go up 5 like this and negative 5 downward. Okay, now we have all that we need. Let's plot that. This is our 0, right? So 1, 2, 3, 4, 5. This is going to be our highest point. And from the 0, negative 1, negative 2, negative 3, negative 4, negative 5. And this will be our lowest point. Now, next, we just have to sketch it smoothly. Let's bring in the marking scheme. This is 2-mark question. The first mark is coming from the correct sine curve, where it has this S shape. and amplitude at 3. So this is 3 and -7, which is this one. That is 1 mark. Second mark is coming from when it's a 1 cycle and with the correct midline of -2, which is this part.